To make it easier to understand the effects of changes in interest rates on funded pension systems, we consider two examples. In the first example, changes in interest rates will not have any effect, whereas they will have an effect in the second example. Let us start with the first example and consider two cases, A and B. For both cases, we start with an initial savings amount of 1,000. In case A, we receive 5% interest in the first year and 2% in the second year. In case B, the sequence is reversed. There, we get low interest rates in the first year, 2% in our example, and higher interest rates in the second year, 5% in our example. How does the future value of our savings develop in cases A and B? In case A, we receive 5% interest in the first year, leading to a future value of our savings of 1,050 after 1 year. In the second year, we receive 2% interest on 1,050, which leads to a final value of 1,071 after 2 years. In case B, we receive a low interest rate in the first year, only 2%, which increases our savings from 1,000 to 1,020. In the second year, we receive 5% interest on 1,020. And the final value of our savings after 2 years is again 1,071. This example leads us to the following insight. If we have a single savings payment to start with, the sequence of different interest rates does not affect the future value of savings. The situation is different if during the savings phase additional savings payments or withdrawals are made. We illustrate this using constant withdrawals of 300 per year, always at the end of each year. In case A, the initial savings of 1,000 grow to 1,050 after 1 year because of 5% interest earned. After withdrawing 300, we have 750 left. Receiving 2% interest in the second year lets the 750 grow to 765. After again withdrawing 300, we end up at a final wealth of 465. In case B, we first get the lower interest rate of 2%, which increases our savings from initially 1,000 to 1,020. After withdrawing 300, 720 are left. On these 720, we receive 5% interest in the second year, growing the 720 to 756 another year later. After withdrawing 300 at the end of the second year, we are now left with a final wealth of only 456. This is less than the final wealth of 465 in case A. What is the reason for this difference in the results? The reason is that in case A, the higher interest rate of 5% is applied to a higher initial wealth of 1,000, whereas in case B, the 5% interest rate affects only a remaining wealth of 720. In case B, the lower interest rate of 2% is applied to the initial savings of 1,000, whereas in case A, this lower interest rate is applied to a lower wealth of 750. We see that the sequence of interest rate is important because the rates are applied to different levels of wealth. This can only happen if additional savings payments or withdrawals occur during the savings phase. Using our newly gained knowledge regarding the effects of interest rate changes, we have a look again at the life cycle model, which we discussed in earlier parts of this course. Remember, the model proved to be useful for analyzing funded pension systems, for example, the second pillar, occupational pension, or the third pillar, private saving for retirement. In the first phase, from age 0 to 20, Peter goes to school and receives initial professional training. Receiving no income, Peter cannot build up significant savings for retirement during this phase. In the following phase of his professional career, Peter receives income and he can use part of this income to save for retirement. These savings cause Peter's wealth to grow. Upon reaching retirement age, Peter's income from work stops and spending in retirement must be financed out of wealth accumulated, including any interest earned on this wealth. Typically, Peter's wealth will decrease during his retirement phase, which ends in our example with Peter's death at age 90. Any wealth left at this time is passed on to the next generation. What are the effects of interest rate changes during these different phases of life? Let us assume for simplicity that interest rates can only be either high or low. Low interest periods are marked in red, and high interest periods are marked in blue. Let us compare two different cases. In case 1, interest rates are low during the first part of Peter's professional career, and then again towards the end of Peter's life. In between, in the second half of Peter's professional career and in the first half of Peter's retirement, interest rates are assumed to be high. The period of high interest rates coincides with the period when Peter's wealth is relatively high. This means that the high interest rates are applied to high wealth levels, leading to high interest payments earned by Peter. Compare this to case 2, where the development of interest rates shows the exact opposite pattern. In case 2, interest rates are high at the beginning of Peter's professional career, and then again towards the end of his life. In between, in the years around reaching retirement age, however, they are relatively low. In this case, the low interest rates are applied to high wealth levels, leading to lower interest earned compared to case 1. The high interest rates, however, are applied to wealth levels that are not yet as high or no longer as high. Comparing the two cases, Case 1, where high interest rates and high wealth levels occur at the same time, is clearly advantageous for Peter.